In this chapter, we are going to discuss a special type of, let's say, problem-solving method. This is called as linear programming, and we'll be going through an example, a casting problem, while discussing the linear programming, and try to come up with a nice solution for such a casting manufacturing problem. So you have, I think, some knowledge about manufacturing, and in automated manufacturing, we have the objects, we have the parts most of the time fabricated by using casting methods, or we may also use some different manufacturing systems like machining. And in all these processes, computers are highly important. We use computer design and manufacturing tools. And the thing is that while selecting the manufacturing process, we should be careful about the type of material we are going to use for the fabrication of the product. And we should also check the shape of the product, whether it is manufacturable or not. And also the number of products we are going to produce is another important issue. If you are producing just a single one, you may use a special process, but if you are producing, let's say, thousands of it, then you may switch to a bit different manufacturing process. And regarding the casting processes, the most important, the critical part is the shape or the geometric properties of the parts. By looking at it, you may say that whether this one is castable, whether you can cast it with the help of molds or not. Sometimes you may have multiple molds, but it's a bit costly. So we prefer to have a single mold, so that by simply pouring the material into that mold, you can do the casting operation. Like this one here, this is our mold, and this is molten material in liquid state. We are simply pouring it into the opening here. This is our cavity in the mold. And as you see, after the part is solidified, we can simply move it upwards and take it out. So what do you think? In this configuration, can we take this one out? Let me show it by arrow. Yep. Can I have such an orientation to move this part out of the mold? Obviously not possible. What about such an orientation? Okay, not possible. I can only move it upwards, right? Since we have restricting planes, these planes here are restricting the movements of the, let's say, part in different orientations, but it's only possible in positive z direction, right? Others are not possible. We have restrictions due to these side, let's say, surfaces. So now the problem is you will be given an object, and then you are going to state whether this object is castable or not. Or the question is, can you find a mold for it from which it will be easily removed in a kind of a direction, specified direction. Let me draw another one here. I will draw just a cross section. Oops, let me increase it and draw once again. Assume that this is the cross section, okay? This is the cross section of the mold. So can I use this orientation, which is positive Z, let's say, after the part is casted? Obviously, I cannot. Since again we have a restricting surface here, it actually does not let us actually move this part in that positive Z direction. Instead, what we are going to do, if you have a moving direction which is parallel to these surfaces, you can easily move your casted product out of the mold. For other orientations, it's not possible. Again, this is fine. This is not okay. cannot also move in this direction. These are not possible. You can only move it in a direction which is parallel to these side surfaces. So now in this, while solving this problem, while working with some solutions, we'll be assuming that the given objects are always polyhedral, which means that they have planar surfaces, and we have such polyhedral assume that this is kind of a polyhedral. As you see, all these surfaces are planar, and with the help of n number of planar surfaces, we have a closed volume. That's why we call all these as polyhedral. And another assumption is that we can only use one-piece molds. We don't have an option to use, let's say, two molds. So in some cases, for complicated shapes, you may have such a mold, which means that you have two of them. So after the part is casted, you may simply remove one of them and then remove, let's say, the second half and then the first half. So with this way, things might be easy, but in our assumption, in our problem, we will be assuming that we can only use one-piece molds. And this is another assumption. We can only have a single translation. We can't have, let's say, such a movement. This cannot be actually done in our problem, or such a movement is not possible. We can only have single translations. The orientation is not important, but we can only have such single translations. So if you look at this example, obviously this is not castable since we have restricting planes, but the other one is an easy one. You can simply move it upwards and complete the casting operation. So if an object is castable, then we can say that we should be finding a suitable mold for it. And obviously the shape of the cavity will depend exactly on the shape of the object. Since we are trying to manufacture that object, the shape of the cavity and the shape of the object should be the same. If you have different orientations, then you might have different molds. And another thing we need to know before going into details is that in the selected orientation, the object should have an horizontal top facet. So if, again, this is our mold, this is mold, and the other one is cavity, as you know. So once you do the casting operation, so this should have a top facet, and this is top facet of the object to be casted. And the thing is that it should be horizontal. It should have the same planar configuration with the top of your mold, okay? This is another important issue. And from definition, we can say that the top facet shouldn't have any contact, obviously, with the mold. It should be open to air. So another thing, if the object is castable, then you can remove it from the mold by using a kind of any orientations, whether pure plus Z direction or oriented any angled direction, it doesn't matter, but we should find a way to take this part out of the mold if it's a castable part. If it's not castable, then we cannot talk about these orientations, but once it's castable, then you should be finding a specific direction so that you can remove it. So this is what we mentioned. Now our main focus will be actually to find that specific direction, if we have any. Sometimes we can also conclude that we cannot find such a mold. This product, this given shape is not castable with a single mold. So what is the easiest thing? You can check all the potential orientation, but this is a brute force method. It will take obviously lots of time. You have infinite number of, let's say, possible orientations. If you spend time on it, then probably your computer will give some errors and you will not be able to find that specific orientation, or you cannot even conclude that this part is not castable. Now we are going to discuss some details. Any questions, guys, before that? About these fundamentals of the casting problem? So now we are assuming that we have a polyhedron P. This is our product to be casted. This is P. Another thing is that we are assuming that our mold is a kind of a rectangular block, but it should have a cavity which is corresponding to the shape we are working on, P. So once you place that product in the polyhedron in the cavity or in the rectangular block, then you should have a top facet which should be coplanar with the topmost facet of the mold. These are things actually we mentioned, and for the conventional problem they should be parallel to the XY plane, but it doesn't have to. You may also have different planes, but the thing is that they should always be coplanar with the topmost facet of the mold and the top facet of the polyhedron. So in the polyhedron, you have a top facet. This is top facet, but the other ones will be called as ordinary facet. So this is an ordinary one, another ordinary, but this is top facet, okay? Another issue is that since your part is inside the cavity, again, let me draw the same type of mold and cavity. So this part is called as F hat. And if this is our part actually here, and the face of the polyhedron is called as ordinary facet F, and each ordinary facet should have a corresponding facet on the mold side, and we represent them as F hat. As you see, we don't have obviously a corresponding facet on the mold for the top facet, since obviously this is open to air, it has no, let's say, neighbor. So we are going to do computations, come up with some solutions, and later decide whether the given polyhedron, whether the given shape can be removed from the computed mold with a single translation, whether in positive Z or different orientations. So actually, this is the thing we should find in the computations. We should find a direction vector D, and this direction vector should help us for the removing of the part, removing of the polyhedron from the casting. So the thing is that you should be able to remove the polyhedron P to the infinity in this given direction D. Another important issue, you shouldn't be intersecting with the interior of the mold, otherwise you will harm the mold and you will not be able to use it again. If it's not a sand mold, obviously, but if it's a sand mold, then the orientations is not important. You can simply collapse your mold and remove your part. And this problem is for reusable, let's say, molds. So we don't want to do harm on the surfaces, and we should find a specific orientation so that we will take our part out of the mold. Another issue, you may have some angled orientations, but they should at least have a positive z component. So if they don't have any z component, then that means you are pulling them in x and y directions purely. And if that's the case, obviously you will not be able to move it out, since in order to remove it, you need to do at least some motion in z axis. So these are things we mentioned. We have the polyhedron here, P. We have the ordinary facet, top facet, the facet of the mold. As you see, they are represented with F hat, and we should have 1, 2, 3, 4 F, let's say, has, and 4 ordinary facets. And you can remove this part by sliding along that planes, or by moving away that plane. So let me draw it here. If you have another, let's say, this is F2 hat, and this is, if this one is F2 simply, then if you are removing, let's say, your part in this direction, then that means you are sliding along this face, but you are moving away from this F2. So sometimes you may be sliding along or moving away depending on the angle or the position of your facet. So in the remaining of this discussion, we need to have a kind of a definition for the angles. This is actually our simple definition. If you have any vectors, let's say I draw another one here. So if you have such a vector, let's say A and B, and if we mention an angle between A and B, we will be always referring to the smallest angle in between. And in this example, we are referring to here, but not the larger angle, okay? Not the larger one here. So once you see an angle in our, let's say, upcoming slides, upcoming algorithm, we will be always referring to the angles, the smaller angles between any vectors. So let's focus on some details then. And if you look at this complicated part, this is our polyhedron to be casted, and we have some facets, ordinary facets, and we have the corresponding facets on the mold, and it's a single point, it doesn't matter. And then this is our, let's say, removing direction vector D, and we want to remove it in that direction. And now we are going to check whether it's possible or not. So what do you think? Assume that this is in place here. Can we remove it in that direction? Can anyone tell me whether it's possible or not? And assume that we have this part removed. Okay, this is vertical. So if I put it here, can I simply remove it in that orientation? Any answers, guys? Are you with me, by the way? So what are we doing up to this point? Can anyone tell me, summarize, and answer my question?
Jam, shouldn't it slide out somehow, even if the force is a bit vertical?
Cannot slide out in that orientation, since let me draw it here. This will be the actually part in the cavity, right? Can you move it in that direction? And we have walls here. Or let me draw, yes.
If it's restrained from the back with a wall, no, we can't. I don't think so.
Yes, we have some restrictions, and this is how we are going to do the check actually. So assume that this is our, again, cavity, and let's have the same angle here. Can we remove the part in this orientation? And we said that this is not possible. But how we are going to do the check, whether the given angle is fine or not? So we are going to do the check with the help of the angles, with the help of the angles of the normals. So what is that actually? Obviously, f hat, which is this face, this is f hat, let's say, and it will be blocking the translations in any direction, making an angle of less than 90 degrees with the normal of f. This time not f hat. So this is our, let's say, part. And I can say that that will be the normal. We have a 90-degree right angle between this. This is f hat, and this is the ordinary facet of the part. So this is our eta of f, the normal vector of the ordinary facet. So if you look at this direction vector, and we said that once you define an angle between two vectors, we are always referring to the smaller one. So this is the angle. And if you look at this definition, f hat will be blocking the translations if you have an angle of 90 degree or less than that with the normal vector of our ordinary facet. And as you see here, this is less than 90 degrees. And that's why we cannot remove our part in that direction, since our f hat, the corresponding, let's say, facet on the mold side, will be blocking our motion. But if it's more than 90 degrees, it's not going to block, or it's just equal to 90 degrees. Let's have a look at here, for instance. If you have another direction, D1 vector, and now you see that we have 90 degrees between the normal of f and between that given direction. So this is not less than 90. We can say that it can slide along that orientation. Or if it is more than 90, can we remove in D2 direction? So what do you think about D2? Can I remove in direction D2?
Teacher, is it still less than 90 degrees, so it cannot be removed?
No, it's more than 90 degrees. This is normal. And if you look at here,
sorry.
This is more than 90 degrees.
Sorry, I looked with the D1.
Yes, but the problem is that we don't have any issue with this facet, but we have another issue at the other facet on the right-hand side. So the thing is that you should be checking all this angle, let's say, requirement for all the faces. If you check it all just for a single one, then you may fail. And this is actually what we are going to do in the remaining of this chapter. And I want to stop right now.